Okay, in today's video, we are going to look into constituents of atom. Regarding the Rutherford atomic model, we suggested that atom is made up of a tiny positively charged nucleus surrounded by negatively charged electrons that has small mass. Then it is clear that an atom is made up of what? Proton, neutron, and electrons. The proton and the neutrons are situated within the nucleus, and this is what constitutes what we call nuclear charge, while the electron revolves around the nucleus. We are going to look into these three particles that constitute an atom, that made up an atom in some ways. We are going to consider their relative mass, relative charge, absolute mass, absolute charge, and where they are located. That is where you find them in atom. In terms of their relative mass, the proton has the mass of 1, and electron has the mass of 1/1840. That is very negligible mass. While the neutron has that mass of 1. Then, in terms of their relative charge, the proton is positively charged. The neutron is nil because it has no charge, while the electron is negatively charged. And remember that we said that this proton and the neutron is what constitutes the nuclear charge. Remember, it now means that the nuclear charge will be positively, that is, the charge within the nucleus will be positive charge, because the neutron don't have any charge at all, but the proton is positively charged. So it means that within the nucleus will be filled with positively charged particles. Okay, then in terms of their absolute mass, that of the proton has 1.673 multiplied by 10 to the power -27, while that of the neutron is 1.675 multiplied by 10 to the power -27. But that of electron is 9.11 multiplied by 10 to the power -31. Then when it comes to their relative charge, that is their absolute charge, the absolute charge of proton is 1.602 multiplied by 10 to the -19, which is the same absolute charge of electron, but that of neutron is 0, that is nil. Then in terms of their location, we have already said that the proton is found within the nucleus. The neutron is located within what? The nucleus, but the electron revolves around the shell. Okay, this is just the summary of what we have discussed so far. We considered the three particles in accordance with their relative mass, relative charge. I use this R as a relative charge. So this is relative charge, absolute mass, absolute charge, and the location. That is the where you find them. Okay. Then we have that proton has the relative mass of 1, neutron has that of 1, while electron has that of 1 divided by 1840, which is very small. very negligible. Then the relative charge of proton is positive 1. Neutron has no charge at all. That's why it's 0. While electron has negative 1. But the absolute mass of proton is 1.673 multiplied by 10 to power negative 27. That of neutron is 1.675. 1.675 multiplied by 10 to power negative 27. While that of electron is 9.11 multiplied by 10 to power negative 31. Then when it comes to their absolute charge, the absolute charge of the proton and the absolute charge of that of the electrons are the same. That is 1.602 times by 10 to power negative 19. But the absolute charge of neutron is 0 because we said it has no charge. Its charge is nil. Then the position where you can find them, we already said that protons can be located at the nucleus, the same thing as the neutron, but electrons is at the shell because we said it revolves around the shell. Then this means that if we decide to structure an atom, we can represent an atom as this. So this is the nucleus, the area that we have positive charges due to the presence of the neutrons, presence of the protons. Then this, you can see this line is now what is called the atomic shell. So in that case now, it means, remember we said that the electrons revolves around the shell. So it means the electron is revolving around this shell. And this is the reason why when we are talking, remember when we used to represent atomic shell of an element, when we draw, we represent electrons as, you can see that it's on the shells that I am drawing the electrons, denoting the electron using these 0 symbols. Are you getting it? So you can see electrons is revolving around the shells. Okay. Now let's look at atomic number. But since atom is electrically neutral, it means that the number of the proton must be equal to the number of electrons such that they can cancel each other. Remember, we said that atom is electrically neutral. That means that atom don't have any charge at all if it's neutral. If it's electrically neutral, it means it's neither positive nor negative. And remember, we have already talked about 3 particles that make up an atom. We said that the third particle is nil, which is the neutron. It has no charge. And the first particle, which is the proton, is positively charged, while the second particle, which is the electron, is negatively charged. So in other words, atom is supposed to have its own particular charge. But for it not to have any charge, it means that the number of the positive charges must be equal to the number of the negative charges so that they will cancel themselves and make the atom not to have charge at all. What I really mean is that let's consider an atom of hydrogen. At first, you know that hydrogen is the first element. And this is an atom of what? Hydrogen. So it means that if hydrogen has only 1 electron at its shell, if you come to the nucleus of the hydrogen, we will have only 1 positive charge. Do you understand? So it means that when we look at the atom of what? Helium. For helium to have 2 electrons at its shell, it means that at the nucleus of what? The helium, we will have 2 positive charges. So you know that this electron is negatively charged, has negatively charged particles. So if there are two negative charges here, then it means that for this atom to be electrically neutral, there should be two positive charges also within the nucleus, so that the negative will cancel the positive. That is, the negative will nullify the positive, so that none of the charges has effect and the atom will become electrically neutral. So regarding what we have just explained so far, how many protons, positive charge, do you think is present in an atom of carbon? Carbon has 6 electrons revolving around the shell, and that is it: hydrogen, helium, lithium, beryllium, boron, carbon. So how many positive charges do you think will be found within the nucleus of the carbon? And what the number you think will be present there will give you the proton numbers. Okay, now let me tell you, if you don't know, the number of the positive charges that will be found in the nucleus of the carbon will be 6, because you have 6 number of what? Electrons. So there should be 6 positive charges within the nucleus, so that the positive can cancel the negative. Is it clear? This atomic number that is determined by the number of the positive charges, that is the number of the protons, is very important in chemistry, because it helps you to know more about the characteristics of the elements. Remember, the atoms of the same elements have the same atomic number. Now let's look at the atomic number of the element. Now let's consider something. Remember that atomic number is denoted by Z. So I use Z to represent atomic number. This is element, the symbols of the element, the atomic number, which is Z, the number of electrons present in the atom, the first shell. The first shell of the atom is called K shell. That way you use to recite English alphabet: K, L, M, N. So this is L shell. Then the third shell is called the M shell. Then the fourth shell is called what? N shell. Now let's pick hydrogen. Hydrogen is the first element. We have hydrogen. So because that is the first element we called, its atomic number is 1. And the symbol of hydrogen is what? H. Okay. Then the number of what? That is the atomic number, which tells you the number of protons present. The atomic number, because the hydrogen is the first element, its atomic number is 1. So because its atomic number is 1, the number of electrons present in hydrogen is 1. Okay, so the number of shell, its first shell is what? Has 1 electron. Now let's consider that of helium. Helium has 2 electrons. Hydrogen, helium. So it means helium is the second element, right? So its symbol is He. Then the atomic number of helium is 2. The number of electron is 2. You have 2 numbers of electrons there on the shell. So helium has 2 electrons in its what? First shell. You can see it. Now let's consider the lithium. You can remember that the first shell accommodates maximum of 2 electrons. 2 electrons is what gets filled up the first shell. It cannot accommodate more than 2 electrons. After filling the 2 electrons, we move to the next shell. Every other shell will accommodate maximum of 8 electrons. Okay, Now, when we come to lithium, the atomic symbol for lithium is Li. Then the atomic number is 3 because that is the third element. So the atomic number is 3. And since the atomic number is 3, the number of electrons there is 3. The numbers of the electrons in the first shell is 2. Then in the third shell, we have what? That is L shell. We have only 1 electron. You can see it. Now, let's consider the next element, beryllium. The symbol of beryllium is what? Be. And look at the atomic shell of beryllium. We have hydrogen, helium, lithium, beryllium. So the atomic number, being the fourth element, the atomic number of beryllium is what? 4. The number of electrons in each shell are 4. The number of electrons in the first shell of beryllium is what? 2. The number of electrons in the second shell of beryllium is R2. Then, looking at the boron, boron has a symbol of B and is the fifth element, meaning that the atomic number of boron is 5. The number of electrons in the first shell, okay, the total number of electrons in boron are 5. Then the number of electrons in the first shell of boron are 2, while the number of electrons in the second shell of boron are 3. In that same way, the symbol of carbon is C. The atomic number of carbon is 6. Then the total number of electrons in the carbon are 6. The number of electrons in the first shell of carbon are 2. And the number of electrons in the second shell of carbon is what? Are 4. Okay, in the same way, you continue until you enter the third shell. If you enter the third shell, you draw column for the third shell, which will be the M shell. Then you continue adding the number of electrons until you enter the fourth shell, which will become the N shell. That way you continue. Okay, I hope you understand what we are doing. Having known what atomic number is, let's discuss mass number. The mass number of an atom of an element is the sum of the proton and the neutron numbers present in the atom of that element. What do I mean? Remember, we said that atomic number is denoted by what? Z. Remember also that this atomic number gives us the number of the proton present in an atom of an element. So when we are talking about the proton now, I'll be using Z to denote what? The number of proton. And the mass number of an element is what? Denoted by A. And neutron number is denoted by N. Then it means that the mass number is equal to proton numbers plus the neutron number. In other words, in a short form, we can now write A is equal to Z plus N, or A is equal to N plus Z. They are the same thing. So you will be seeing an atom of an element represented in this form, or any other letter can be used. But what you should know is that this upper script here is the mass number, and this subscript here is the atomic number, which is equal to the proton numbers. Example, hydrogen is this. If somebody asks you to find the number of protons present in hydrogen? What is the answer? The answer is 1, because the number of protons is equal to the number of atomic number, is equal to the atomic number, and the atomic number is 1. It means the number of the protons present in hydrogen is 1. Okay, then the neutron number is 0, because 1 minus 1 will give you 0. Then this is an atom of sodium represented in this form. So somebody will ask you, how many numbers of electrons are present in the atom of sodium? It is 11. How did I know? I knew it because this atomic number of sodium is 11. And the number of protons present in sodium is 11. That is the positively charged particles. And we say that an atom of an element is what? Electrically neutral. That means the number of the positive particles must be equal to the number of the negative particles. And the electron is the negative particles. So it means that the number of electrons must be equal to 11 for sodium to be electrically neutral. Now, if somebody asks me how many neutrons are present in sodium, what will I do? I will use this formula. Mass number is equal to the proton number plus the neutron number. Then I will make the neutron number subject formula, thereby moving proton to this side. So in that case now, the neutron will now be equal to the mass number, which is A, minus the proton number, which is Z. And the mass number here is 23. That means 23 minus the proton number, which is Z, minus what? 11. And that will give us what? 12. So the number of electrons present in sodium atom is 12. So in the same way, you can calculate the number of what? Neutron present in carbon atom by saying the mass number 12 minus the atomic number 6, and that will give you 6 number of neutrons. I hope this is clear, right? So I will give you one now that you will solve. I do this. This says an element is represented as this. If it has 12 numbers of electrons, calculate the numbers of neutrons present in the element. How many protons has the element? What is the name of the element? Write its electronic configuration. If you like this video, click on the like button and click on the subscription button. Then click on the notification bell so that when next another one is uploaded, you'll be notified to come and watch.